See, the up to third unit, we have discussed about the solar part, wind part. Those are the two important things what we have discussed up to two. Now, in the third unit, we are going to discuss about the biomass. Now, whenever I'm talking about the biomass is considered now, the energy, whatever we are going to get it from this particular biomass, we normally call that as a bioenergies. Now, when I'm talking about the word bio, it is indicating it is going to be an organic material which is going to be available. It may be a trees or it may be plants or something else. So wherever you are going to see a biological source is there, so that source, biological source, is called biomass. And the energy derived from the biomass is called bioenergies now. So these bioenergies may be a plants, trees, or crop residues, or whatever it is. All the things comes under this particular categories now. So when I'm among all these things, once again, municipal waste is also comes under this particular categories, biomass categories. Now, when I'm talking about this, why? Because when we have seen the solar part and wind part, which was easily available, naturally it was available. So we call that as a natural or renewable energy resources. Why we are going to call the biomass is also going to be a renewable energy resources. Now, when I'm talking about the definition of renewable energies, first and foremost important things is how the term came, renewable. So renewable means regenerated one. Whatever the energy which is going to be regenerated, whatever the source which is going to be regenerated, we call that as a renewable one. Suppose if I'm taking a wind, today I use the wind energy I used with the help of my windmill, we produce the electricity. Now that was done up to that wind part. Tomorrow also we are going to have the wind, and now it is going to be regenerated once again, and we are going to use it. Similar situation is there for sun, solar part, and all. Now, in the similar fashion, biomass is considered now. This biomass is also going to call it as a renewable one because it is abundantly available. Just you can take an example of your crop residues. You can take uh, just like your sugar canes, where I'm saying that sugar cane, after utilizing of the sugar cane, I'm going to have the bagasse enough. Now, whenever, up to whatever may be the methodology, whenever up to sugar cane, whenever you are going to have it, this bagasse will always be there. Now, sugar cane will always be there because all the ingredients, all the materials is going to be prepared with only sugar cane. Just like you can take an example, sweets I'm taking. These sweets, it's going to be prepared with the sugar cane. Sugar cane, they are going to produce the sugar. From that sugar will be having lot number of applications. If you consider we are not having the sugar, nothing will be there now. No ingredients, sweets, cakes, nothing will be there. Nothing but every farmer has to prepare this particular sugar canes always. When I'm preparing the sugar cane, I'm always going to have this bagasse part. After removing of the juice, I'm going to have the residual one, whatever it is, remained one, we call that as a bagasse part. This always be there. Now, if we are observing it carefully, these particular things, if I start burning it, I'm not going to get it any type of pollution, any type of pollutions at all. Nothing but I'm going to have it lot number of plants we can able to generate, and here we can say that lot amount of electricity we can able to create, lot amount of applications are there for this. That's why this biomass is also creating a very big renewable energy resources here, right? That's why we are studying in the fourth unit. Now, if I'm observing it here, I'm going to have different types. See, now when I'm talking about this, now our main intention is to go for generating of the electricity with this. Now, when I want to generate the electricity here, first and foremost things, you need to burn it first. When I'm burning, then only I'm going to get the energies. Without burning, if the resources is available, without burning, I'm not going to get anything. If you burn, you are going to get the energies. Now, important question, where you are going to burn it, right? If I'm burning just like a normal atmosphere, whatever the heat that is generating is going out. You cannot able to You cannot able to trap it out. You cannot able to take it out. Now what to do now? I need a separate combustion chamber here. I need a separate place where I'm going to keep all the biomass there, and I'm going to have the burning. And after the burning process is over, it can be there the gases, whatever it is going to come, hot gases, that can be utilized for the running of your turbine or something else where you can able to generate the electricity. That is the way this biomass direct combustion process, where you are going to have direct combustion, where you are going to get the energies here. So when I'm talking about this, I'm going to have a different type of strokers here. What is a stroker? Stroker is nothing but a combustion chamber, because the topic itself is called biomass direct combustion. Just now I told you, when I need combustions, I need a combustion chamber. Now these combustion chambers may be a different types. One is underfeed stroker here. What is this underfeed stroker? Now when I'm talking about underfeed stroker, it is also called as a mechanical stroker, where it looks like a very simple. From one end, here we are going to supply the coal. To take an example of a biomass, you can take an example of a coal, and this coal is going to be screwed in so that all the things, all the resources is going to move up into the furnace, where it is going to burn it. When it burns, I'm going to say that lot amount of energy is going to come. When lot amount of energy is going to come, so these particular hot gases we are going to supply for the boiler. And now from the boiler, we are generating the steam. Steam is going to be generated electricity. That's the secondary circuit. What I call secondary circuit also. See, the total biomass combustion is going to be having two circuits here. One circuit only for combustion, second circuit only for power generations. In the first circuit, we are going to have the furnace, and in the furnace, we are going to have the power generations, or we are going to have this heat generations. This is the first circuit. Now, after the heat generations with the help of a flue gases. Now, these gases, what we are doing, we are sending to the second circuit, where we are going to have the power generation with the help of the boiler, right? But only one difficulty here we are going to identify this underfeed stroker is, so this underfeed stroker is a smaller one. First, this is not continuous one, because once if you are sending the coal in, so you have to wait up to all the things is going to convert into the ash content. Then you have to remove all the things. Once again, you need to send it to the second one. That's why the amount of power what we are going to get it is not going to be that much, right? So this is another first one. Now let me go for seeing the another one, grid stroker. So whatever the disadvantages we identified in the underfeed stroker, those difficulties we are going to avoid it here, right? What difficulty we identified? That was not continuous, first one. Now it is saying that this is continuous. Now there I am not going to have it the automatic removal of your ash content. You need to remove the ash content. If you are not removing it, the ash is going to block everything. But now here when I'm talking about a great stroker, where we are going to have it continuous removal of ash content also, and continuous supply of the coal. Nothing but your power generation is going to be continuous, right? Now let me go for saying this is going to be a two type of classifications here: chain grade or traveling grade stroker and spreaded stroker. This is one of the very important things. If you please remember it, whatever we are going to discuss about these particular chambers, either it may be underfeed, or it may be a traveling grade, or it may be spreaded stroker, or it may be a fluidized bed combustion chamber. So among these four, you are going to have it one. You are going to get it one question, please. Please remember it. In the traveling grade stroker, how it is going to be now? Just now I told you, I'm going to have it two circuits. One circuit where we are going to supply the coal and we are going to heat it. Only heat generation process is going to be done in the first category or first circuit. Now, when I'm going for the second circuit, where whatever the heat it was generated here, this heat is going to be supplied to the secondary circuit. It's going to be supplied for the secondary circuit. When I'm supplying the secondary circuit, where in the secondary circuit we are generating the power, right? Now, if we are observing it carefully, here also we are going to have it two circuits here. So the first circuit, you can observe it, first circuit, what it consisting of. So first circuit, it is a left side, right side portion is the second circuit. In the first circuit, what we are identifying, what components we are identifying. Look at that, the figure. So the first, it is identified like a coal hopper. What is this coal hopper? Coal hopper, it is indicating just like your storage bin, where you are going to keep all the coal in, and it is going to be stored, and it is going to connect it to your spreader stroker, your sprocket wheel, or your chain grate, and it is going to supply the coal continuously now. It is going to supply the coal continuously. It is just like, you can take an example here how it is going to be done. So how the coal hopper will work. కోల్ హాపర్ ఎలా పనిచేస్తుంది అంటే మీకు అందరికీ చాలా సింపుల్ ఎగ్జాంపుల్. మీరు ఎప్పుడైనా మీరు ఒక గోధుమలు కానీ బియ్యం కానీ పిండి మిషన్ ఆడించుకోవడానికి పిండి మిషన్కి వెళ్ళారనుకోండి, మీరు ఏం చేస్తారు, మీరు పిండి మిషన్కి వెళ్ళిన వెంటనే అతనికి పిండి ఆడించేవాడికి మీరు క్యాన్ ఇస్తారు. మీరు గోధుమలు ఉన్నాయనుకోండి, గోధుమ పిండి కొట్టించుకోవడానికి గోధుమలు తీసుకెళ్ళారు. గోధుమలు ఏం చేస్తారు, అతను ఫస్ట్ పైన ఉండే హాపర్లో పోస్తాడు, రైట్? నా హాపర్ హౌ ఇట్ ఈస్ గోయింగ్ టు బి, హాపర్ ఎప్పుడు కూడా ఇలా ఉంటుంది. సో కింద సైడ్ ఇట్ ఈస్ గోయింగ్ టు బి ఏ స్మాలర్ హోల్ where it is going to allow little bit amount of the wheat for grinding operations, right? Similar things, that is called hopper. That is called hopper. Now here also I am saying that in place of the there in a flour mill where you are keeping the wheat, here we are going to keep it coal. All the coals we are going to keep it there, and now from the bottom side we are going to have it adjustable grate here. మీకు పిండి మిషన్లో కూడా ఉంటుంది అడ్జస్టబుల్ గ్రేట్. ఏం చేస్తారు వాళ్ళు, ఒకవేళ ఎక్కువ స్పీడ్కి పంపించాలనుకోండి, ఎక్కువ ఓపెన్ చేస్తారు. ఎక్కువ ఓపెన్ చేస్తారంటే స్పీడ్గా వెళ్ళిపోతుంది నీకు ఎక్కువ దాంట్లో. సో నాకేమైతే ఎక్కువ వెళ్ళిపోయింది అనుకోండి, ఎక్కువ క్వాంటిటీ వెళ్ళిపోతుంది కాబట్టి నీకు గ్రైండింగ్ చేసేటప్పుడు పిండి సరిగా ఆడదు. సో లేదు, వాళ్ళు ఏం చేస్తారు, కొంచెం మీడియం సైజ్ కొంచెం తక్కువ పెట్టుకోవాలనుకుంటే అడ్జస్టబుల్ గ్రేడ్తో కొంచెం అడ్జస్ట్ చేస్తారు, కొంచెంగా లోపలికి వెళ్ళేటట్టు. Similar things, here also we are going to have the adjustable grate. What it does, it is going to adjust, it is going to keep it, the sufficient quantity of the coal is to enter onto the furnace. We don't want this, what it does, it is going to say that the thickness of the layer of the coal, whatever it is going to form it here, it is not there, that is not going to be formed too much thickness. Thickness will be lesser. Less thickness they are going to find, because if more thickness is there, burning is not going to be taken place. మీరైనా ఎప్పుడైనా అబ్జర్వ్ చేయండి, నేను ఎప్పుడైనా బర్న్ చేయాలనుకున్నాను అనుకోండి, కర్ర ముక్కలు బర్న్ చేద్దాం అనుకున్నాను, నేను ఒక 4-5 కర్ర ముక్కలు పెడితే నాకు ఈజీగా బర్న్ అయిపోతుంది. అట్లా కాకుండా ఒక పెద్ద మోపు తీసుకొచ్చి దాన్ని పెట్టాను అనుకోండి, వాట్ ఇట్ ఈస్ డూయింగ్, థిక్నెస్ is increasing. If thickness is increasing, oxygen entering into that is going to be less. Because of less oxygen, it won't go for combustion process. Similar things, here adjustable grate is going to adjust the thickness of the coal that is flowing over the furnace. Now how the furnace is there? Furnace is consisting of a sprocket wheel. One end of the sprocket wheel is connected to the primary circuit, second end is connected to the secondary part. Nothing but one end, first end is connected to your hopper where it is going to receive the coal. Now it starts moving it into the complete furnace. By the end of that, it is reaching to your furnace end. It is completely, the coal is going to burn it. Only ash is going to remain, and ash is going to fall on the primary circuit end. Now you can find it out. See, sir, we are burning in the furnace. Now when I want to burn it, I need oxygen content. Where I'm going to get the oxygen? This oxygen content, we are going to get it from the bottom of uh, this furnace. You can find it here, the inside the belts, it is going to, sprocket wheel, it is running. Now, inside, below of that sprocket wheel, we are going to have the primary air ports. What these ports are doing? These ports are just allowing the air to enter. Whatever the amount of air required for the combustion process, they are going to be allowed, right? So this way it is going to be done. In the primary circuit, it is going to be operated like this. Now at the end of the time, by the time it reaches to here, so this is going to be completely hot gases is going to come out. When hot gases are coming out, what we are doing? So these hot gases, now it is moving to the secondary circuit, directly to the boiler, where it is going to convert the water into the steam, and now this steam we are supplying to turbine, where we'll get the electrical energies now. This way, these both the primary circuit and secondary circuit are used for these particular things. But among all these things, one basic disadvantage here. మీరు అనుకోవచ్చు ఏం సార్ ఇదంతా బాగుంది కదా, ఒక డిసడ్వాంటేజ్. బేసికల్ థింగ్స్ హియర్ వెన్ వీఆర్ అబ్జర్వింగ్ ఇట్ కేర్ఫుల్లీ. ఇప్పుడు నేను ఎప్పుడైనా మన దగ్గర కోల్ ఉందనుకోండి, బొగ్గులు ఉన్నాయి, బొగ్గుల్ని కొన్ని లావు బొగ్గులు, కొన్ని సన్న బొగ్గులు, కొన్ని చిన్న చిన్న బొగ్గులు ఉన్నాయనుకోండి, వీటన్నిటిని నేను బర్న్ చేయడం మొదలుపెట్టాను. లావుగా ఉండేది బర్న్ అవ్వదు, సన్నగా ఉండేది ఫస్ట్ బర్న్ అయిపోతుంది, లావుగా ఉండేది లేట్గా బర్న్ అవుతుంది. నా ఇప్పుడు ఏమవుతుంది, నీకు నీ స్ప్రాకెట్ వీల్ ఈ ఎండ్ నుంచి ఇట్లా మూవ్ అవుతూ వచ్చింది. మనం ఏం చెప్తున్నాం, ఈ ఎండ్ నుంచి ఈ ఎండ్కి మూవ్ అయ్యే లోపల కంప్లీట్గా బర్న్ అయిపోవాలి. కానీ నేను ఇక్కడ ఎంట్రీలోని లావుగా ఉండే బొగ్గులు వేసాను అనుకోండి, కోల్ వేసాను అనుకోండి, వాట్ హ్యాపెన్స్, ఇట్ వోంట్ బర్న్ బై ద టైమ్ ఇట్ రీచెస్ టు ది ఎండ్. సో ఇట్ ఈస్ గోయింగ్ టు బి లాస్. సో end of this, the coal itself is going to going out as a waste without burning. This is the fundamental problem here, because here it is taking care about only thickness, but it is not taking care about the bigger size or smaller size coals. So this is going to create a problem here. There is always loss for the power generation here. Now what we'll do now, these particular things here we are going to avoid it in the spreader stroker here. What it does, the operation of these particular things and the above traveling rate stroker, both the things is same, but only one small difference. Here we are going to provide a spreader here. What the function of the spreader? So just now I told you the coal is going to consisting of a bigger size coal, smaller size coal. As we know that smaller size coal is going to burn faster rather than bigger size coal. Now what it does, this spreader is going to separate bigger and smaller size coals. And bigger size coal, it is going to allow onto the furnace straight away. Smaller size coal, whose weight is lesser, it is going to spread it. It is going to blow it into the furnace. Now when it is blowing, as it is lesser amount of weight, it starts flying inside the furnace. Now these particular things, now we are going to see very simple. The inside the furnace, onto the grate, it starts burning. Bigger size coals will start burning. Now we are going to get it combustible gases here. Now what happens, these combustible gases will start moving up. Now when it is moving up, what it does, have very high temperatures here. And now this high temperature flue gases, when it is moving up, what is happening, the coal, whatever it is presenting here, this particular coal will start burning. So two places I'm having the burning, one on the furnace and in the air. So I'm going to have it lot amount of combustion process here. Whatever the difficulties we faced in the previous traveling rate stroker, those things we are avoiding it here. This is the advantage what we are going to have it now. Now one more thing, fluidized bed combustions here. What exactly this fluidized bed? Very simple, chala simple ante fluidized bed combustions, where we are going to have it two important things, limestone and coal combination we are going to take it. Or in some of the cases you can find Sand also they are going to have it, flying sand, fluidized form. You can take one small example here. మీ ఇంట్లో మీరు వేరుశనగ పప్పులు వేడి చేద్దాం అనుకుని వేయిస్తూ ఉన్నారనుకోండి. మీరేం చేస్తారంటే ఇంట్లో ఒక పెద్ద ప్యాన్ తీసుకొని స్టవ్ మీద పెట్టి దాంట్లో వేడి చేస్తూ ఉంటారు. వేడి చేస్తూ ఉంటే మీరు కాసేపు తర్వాత అబ్జర్వ్ చేస్తే ఈ ప్యాన్ అనేది యూనిఫామ్ డిస్ట్రిబ్యూషన్ ఆఫ్ హీట్ ఇట్ వోంట్ డూ. ఎందుకు? నేను దాంట్లో వేసేటువంటి టోటల్ థింగ్స్, టోటల్ గ్రౌండ్ నట్స్, వేరుశనగకాయలు అన్నీ ఏంటి కొంచెం థిక్నెస్ ఎక్కువ, అంటే మీరు అన్నీ కలిపితే పై ఉంటుంది. సో ఏమవుతుంది, కొంతసేపు ఒక 5 minutes తర్వాత చూస్తే కిందవన్నీ మాడిపోయి ఉంటాయి, పైవన్నీ అసలు అవ్వవు. పైవన్నీ అసలు అట్లాగే పచ్చిగా ఉంటాయి, కిందవన్నీ మాడిపోయి ఉంటాయి. ఎందుకు? అన్ఈవన్ డిస్ట్రిబ్యూషన్ ఆఫ్ ద హీట్. అదే దాన్ని మనము రోడ్లో బండి మీద మనం కొనాలని ప్రయత్నించాం అనుకోండి, అక్కడ కొంటే బాగుంటాయి. ఎందుకు? వాడు ఏం చేస్తారు, అతను వేడి చేసేటప్పుడు అతను దాన్ని శాండ్ పెట్టి వేడి చేస్తాడు. స్టవ్ మీద ప్యాన్ పెడతాడు, ప్యాన్లో శాండ్ వేస్తాడు. శాండ్ వేసి శాండ్ని వేడి చేస్తాడు. శాండ్ని వేడి చేసి ఆ శాండ్ ద్వారా దాంట్లో అప్పుడు ఈ పల్లీలు వేరుశనగ పప్పులు వేస్తాడు. Now what is happening? First, sand is heating it fast. Uniform supplying of the heat will be done by this particular sand to your groundnuts. The same working principle here also we are going to use it. Nothing but here also we are going to use it either limestone or sand particles. Both the things we are going to use it. Now if you are observing it carefully, here we are going to send both the things into the furnace straight away. Either it may be limestone coal or coal and sand, both the things it is entering in. Now from the bottom side, when I started heating, first this particular sand is going to be heated, and this sand is going to supply the heat to your coal. When it is supplying heat to the coal, uniform supply will be there, and all the coal particles is going to burn uniformly. So nothing will be remained here. So when I am saying that all the things is uniformly going, so naturally what happens? So you are always going to have lot amount of things. So uniform supply, and now we are going to run it. Piping system also inside that. When I'm running piping system, what happens? This water is going to convert into steam, and this steam we can go for utilizing it for generation of the steam or generation of the electricity. Now the remind these particular gases, flue gases, which was consisting of your sand particles also. Flue gases is consisting of sand particles mixed with sand particles, because sand particles density is lesser, so it is flying. Now when it is flying, these sand particles also moves with the gas. Now I need to collect the things now. If I'm not collecting it, what happens? So these sand particles is going to move into the pipes. As the sand particles are too hot, what it does, it is going to stick to the components. And whenever it is sticking, there it starts creating a hole. Nothing but it is going to damage the piping systems. So what to do now? I don't want to have the damage. So we need to recollect our total sand, whatever we incurred here. So we are going to provide a dust collector. This dust collector is going to work like a centrifugal force. Whatever we are going to do in our normal houses also. మీరు ఎప్పుడైనా హౌస్లో కూడా మీరు చూడండి, మజ్జిగ బాగా చిలుకుతుంటారనుకోండి, ఒక కంవం పెట్టి ఇలా చిలుకుతూ ఉంటే కాసేపు బాగా చిలికేశారంటే పైన వెన్న వచ్చేస్తుందండి. మీరు అబ్జర్వ్ చేస్తే ఈ వెన్నంతా కూడా మీరు యూజ్ చేసే గిన్నె గోడల దగ్గరికి వెళ్ళిపోతుందండి, వాల్స్ దగ్గర. Now what is happening? In a central, I am applying the centrifugal force. Because of the centrifugal force, all the things is going to move towards the wall. Now when it is moving towards the wall, what is happening? Now I can able to remove it, all the butter which is coming from that. Now the centrifugal force, it is saying inside central part, it is going to supply the centrifugal force, which is going to push the heavier particles towards the walls. Now, in the dust collector also, as these particular combustible gases, along with your dust sand particles is entering in. Then I'm comparing with the gas sand particles, weight is more. When I'm applying the centrifugal force in, what is happening? The bigger size particles, nothing but sand particles, is going to push towards the end of these particular walls. Now, when it is touching, all the things is going to be collected at the bottom. Now, as it is connected to your furnace, once again, it will be sent back into that. Now, by the time this exhaust gases is coming from the dust collector, it is purely, it's a free from the sand particles. What I call these flue gases, of course, the temperature is going to be more. Now, this high temperature flue gases, now it is going to move towards air preheater here. You can have it out why we need air preheater here. What is the function of air preheater? See, when I'm talking about a preheater, మీరు ఎప్పుడైనా very simple గా అబ్జర్వ్ చేయండి. ఒక చిన్న ఎగ్జాంపుల్. మీ దగ్గర మీరు ఒక పొయ్యిలో కోల్ వేద్దాం అనుకున్నారు అనుకోండి. మీరు బాగా బొగ్గులేసి అంటించేద్దాం అనుకున్నారు. సో మీరేమవుతుంది, మీరు అంటించాలి అని మీరు అనుకుంటే ఫస్ట్ మీరు కోల్ చెక్ చేస్తారు. కోల్ బాగా డ్రైగా ఉందా, వెట్గా ఉందా. అజ్యూమ్ ఇట్, కోల్ ముందు రోజు రాత్రి స్లైట్గా రెయిన్ పడడం వల్ల కొంచెం వెట్ అయిపోయింది అనుకోండి కోల్. వెన్ యూ స్టార్ట్ బర్నింగ్ ఇట్, ఇట్ వోంట్ బర్న్. It won't burn at all because the efficiency of that, it won't burn because it is wet. Now, when it starts burning, it starts burning once if your complete wetness is removed. Now it will start burning. Now, when it is going to be removed, just you need to heat it. Now I don't want too much heat, but I need little bit amount of heat which is going to be needed for removing of the water particles. Now this is called preheating process. So what we'll do in the preheating process, in the preheating chamber, one side the high temperature flue gases are going to come. The second side, the coal which is to be sent into the furnace is going to pass. Both the things are going to mix there, and it is going to make hot this particular coal. Nothing but it is going to remove the water particles completely. Now, when it's completely removed, now what happens? It is dried now. When I'm saying that it is completely dry, now if I start burning, it's going to burn faster. It's going to burn faster. Right? Now, this is a function of air preheater here. Right? This is the way how you are going to have the fluidized bed combustion things. This is also one of the very important things. నేను మళ్ళీ చెప్తున్నాను, మీరు స్ప్రెడర్ స్ట్రోకర్స్లో ఆర్ బయోమాస్ డైరెక్ట్ కంబషన్ ఈ టాపిక్ మీద మీకు ఒక క్వశ్చన్ ఖచ్చితంగా వస్తుందండి. వాట్ ఈస్ బయోమాస్ డైరెక్ట్ కంబషన్ ప్రాసెస్ అన్న, లేకపోతే వాట్ ఈస్ ద డిఫరెంట్ టైప్ ఆఫ్ స్ట్రోకర్స్ విచ్ ఆర్ అవైలబుల్. So you can name many things. You can do now. I have discussed. Sorry. See, now I have discussed about 4 types of strokers. First stroker is underfeed stroker. Second one is a chain grade stroker. Third one spreader strokers. Fourth one is a fluidized bed combustions. So ఈ నాలుగిట్లో ఖచ్చితంగా ఒక క్వశ్చన్ మీకు ఖచ్చితంగా వస్తుందండి. ఒక క్వశ్చన్ వస్తుంది. రైట్. నెక్స్ట్ ఐఎమ్ గోయింగ్ టు హ్యావ్ ది biomass gasifiers here. Now, when I'm talking about biomass gasifier, this functions, this biomass gasification process is another important question. Another important question. మీరు ఎక్కువసార్లు క్వశ్చన్ పేపర్స్లో మనకి అది ఒక క్వశ్చన్, అంటే డైరెక్ట్ కంబషన్ ఛాంబర్ స్ట్రోకర్స్ గురించి ఒక క్వశ్చన్, or else if the Stoker's question is not available, gasifier's question will always be available, because it consisting of your reactions. It also consisting of your reactions. That's why we always say that any one of these two things will be there. What exactly this gasifier is indicating? This I'll go for discussing in the next sessions. This fourth unit, remaining thing gasifiers and biogas generations we'll discuss, and ethanol and alcohol generations, ethanol productions will be there, biodiesel productions will be there, its characteristics. That's why I'll say that fourth unit is going to be the very biggest unit. Fourth unit will be very biggest unit, please. So that is to be taken care. So ఒకసారి దాన్ని చెక్ చేద్దాం. సో ఒకసారి చూసుకుందాం దాన్ని. Okay, in the next sessions, in the next class, I'm going to discuss about this, and the question bank also I'm going to discuss. Right? In the Saturday session, I'm going to discuss about the remaining things also. Last unit, whatever it is available with us. So those things I'm going to discuss there. So please see, all of you, this is a very easier subject. Everybody can score maximum amount of marks. ఎవ్వరు కూడా ఇంతవరకు ఏ సెక్షన్ వాళ్ళు ఎప్పుడు కూడా ఫెయిల్ అవ్వలేదండి. ఈ సబ్జెక్ట్ అంత జనరల్గా ఉంటుంది, మీరు ఏదైనా సరే మీరు రాసుకుంటూ వెళ్ళచ్చు. నో ఇష్యూస్ అట్ ఆల్, నో క్వశ్చన్స్ అట్ ఆల్ హియర్. మీరు ఏదైనా రాయొచ్చు, మీకు చాలా ఈజీగా ఉంటుంది, చాలా ఈజీగా పాస్ అవ్వచ్చు. ఓకే, సో మీకు ఇంకేదైనా డౌట్ ఉంటే ప్లీజ్ రైస్ ఇట్. మీ అసైన్మెంట్ బుక్స్ మాత్రం యాజ్ సంబడి టోల్డ్, కొంతమంది రాశారని కొంతమంది రాయలేదని అంటున్నారు, కాబట్టి ఆన్ 17th యువర్ ఫస్ట్ ఎగ్జామినేషన్ ఈజ్ గోయింగ్ టు స్టార్ట్. ఆన్ దట్ డే ప్లీజ్ సబ్మిట్ యువర్ అసైన్మెంట్ బుక్స్. ఎవ్రీబడి, మీరు బుక్స్లో రాసినా, మీ దగ్గర అసైన్మెంట్ బుక్ ఉండి బుక్లో రాస్తే ఇట్ ఈస్ ఓకే. ఇఫ్ అసైన్మెంట్ బుక్ లేదు అని అంటే ఖచ్చితంగా మీరు దీంట్లోనే పేపర్లో A4 షీట్స్లో రాసి ఉండాలి. A4 కాకుండా మీరు చిత్తు కాగితాల్లో రాసినట్టు మాత్రం ఐఎమ్ నాట్ గోయింగ్ టు యాక్సెప్ట్ ఇట్. మీరు A4 షీట్స్ అయినా రాయండి, బుక్లో అయినా రాయండి, మీ ఇష్టం ఏదైనా రాయండి. ఎనీ వన్ ఆఫ్ దీస్ థింగ్స్ ఈజ్ ఈజ్ ఓకే. అంతేకాని రఫ్ నోట్ బుక్లో రాసినట్టుగా రాయకండి, ఎట్లా పడితే అట్లా చించేయడం. ఎందుకంటే అవి ప్రిజర్వ్ చేయాలి, అది నేను ప్రిజర్వ్ చేస్తాను, అంటే స్టోర్ రూమ్లో పెడతాను, నెక్స్ట్కి మీకు ఉపయోగపడాలి, అందుకని. ఓకే, anybody any things you want to discuss with me, please